In this problem, we're being asked to find the exact value of cosine inverse of -1/2. The first thing I like to do in these problems is to get rid of this inverse notation. So if your inverse function takes -1/2 and sends it to y, that means the cosine function undoes that. So it takes y and sends it back to -1/2. So you can always just rewrite it this way. The next step that I like to do is specify where y is. This is really, really important. So y is equal to this inverse cosine. That means that y is in the range of the inverse cosine. So y is in, and the interval for the range of inverse cosine is 0 pi. This is super important. So like it's all about knowing the range. So now we have to use basic trig knowledge to figure out what this is. So when I think of 1/2, I know from memory that the cosine of pi over 3 is equal to 1/2. So now I know that I have to find an angle on the unit circle that has a reference angle of pi over 3. So we know we're trapped here between 0 and pi. So cosine is negative. It's the x coordinate on the unit circle. Therefore, it must be over here. It's a lot of knowledge in this problem. It's a simple looking problem, but it requires like you have to know a lot of trig to do this. And then so you say, okay, this angle here is pi over 3. That's our reference angle, right? Because that's what we want as a reference angle. And then that means this angle here must be 2 pi over 3. Because if you do pi minus pi over 3, you get 2 pi over 3. So the answer is 2 pi over 3. And notice it's in here. Let me just do a really quick recap of everything we just did because it was a lot. People have a really hard time with these problems. So y is equal to the cosine inverse of -1/2. So the first step is to rewrite it using just the regular cosine. How? The cosine inverse takes -1/2 and sends it to y. That means the cosine function takes y and sends it back to -1/2. Then you specify the range of inverse cosine purely from memory, just totally worth memorizing. Then you say, okay, what's the y that's going to work here? So now you got to think back to like trig. All right, so what angle gives me 1/2? Well, pi over 3. That's from memory. So you know that the trig function values of an angle are the same as the reference angle, except possibly for a sign difference. So you know that the other angle you need has to be one related to pi over 3. It has to have the reference angle of pi over 3. So it has to be in quadrant 2, because cosine is the x coordinate on the unit circle. And this is where it's negative, right? X is negative here. It can't be down here, right? Because this restricts us. So it's not going to be down here. So you say, okay, what's the angle that lives in quadrant 2 that has a reference angle of pi over 3? 2 pi over 3. And if you're not sure how to get that, think of pi as 3 pi over 3. So 3 pi over 3 minus pi over 3 is 2 pi over 3. Boom, there it is. I hope this video has been helpful. In this problem, we have to find the exact value of the real number y. So the way to do this is to first apply the definition of the inverse function. So if the sine inverse takes this number and gives you y, this means that the sine of y is equal to the square root of 2 over 2. So step 1, I always like to rewrite it this way. Then, personally, I think it's a good thing to make a note of what y is. So y is in, and this is from memory. So this is the range of arcsine. So negative pi over 2 to pi over 2. This is probably the most important part of this problem. It's memorizing the range for each inverse trig function. So for inverse sine or arcsine, it's this one. So now you can think about the unit circle and you can ask, okay, what is the angle y that's between these two angles such that the sine of y is equal to the square root of 2 over 2? So if you think about the unit circle, here's negative pi over 2, and here's pi over 2. So you're looking for an angle that's between these two, and it has to be positive. So it has to be up here, right? Because the result is positive. And on the unit circle, sine is the y coordinate. So the angle is going to be pi over 4. And so the answer here is pi over 4. It's really easy to mess up because, you know, if you didn't know this, right, you could say, oh, what about 3 pi over 4? You know, 3 pi over 4 also satisfies, you know, this equation. If you plug in 3 pi over 4 into the sine function, you're going to get this, right? So why isn't it not an answer? It's because it's not between these numbers, so it has to be here. So without this, you might get the problem wrong. So it's super important to memorize the range. That's it. In this problem, we're going to evaluate the sine inverse of the sine of 3 pi over 2. Solution. So in problems like this, you start from working from the inside out. So let's start by working out the sine of 3 pi over 2. So to do this, think about the unit circle. So on the unit circle, every ordered pair has the form cosine theta, comma sine theta. And let's label the angles. So we have 0, we have pi over 2, we have pi, and then here we have 3 pi over 2. So here the ordered pair on the unit circle would be 0, comma, negative 1. So that means that sine of 3 pi over 2 is negative 1. So we can write this as the sine inverse of negative 1. Okay. What I like to do next is I like to give this a name. So we'll call it y. So y is equal to the sine inverse of negative 1. So now you can get rid of the inverse notation. How? Well, intuitively, the inverse function takes negative 1 and gives you y. That means the sine function has to undo that. So the sine function takes y and gives you back negative 1. And now let's specify where y is. So y is equal to the inverse sine. So y is in the range of inverse sine, which is going to be negative pi over 2 to pi over 2. So now we're looking for the value of y such that the sine of y is equal to negative 1 in this range. Well, that would be negative pi over 2. This angle here is also known as negative pi over 2. So the angle here, and the answer in particular, is negative pi over 2. And that's the final answer. This is a really nice example because notice it's really tempting to just cancel here, but if you would have done that, you would have gotten the wrong answer. I hope this video has been helpful. Good luck. In this problem, we're going to work out cosine inverse of the cosine of negative pi over 6. Let's go through it very slowly. So solution. So the first thing you want to do is make sure not to cancel. So don't just cancel these in these problems. Super bad. It will not always work. So let's focus on the inside piece. Cosine of negative pi over 6. Okay, so there's actually a trick we can do here to make things easier. We can write this as cosine inverse. I just realized this. Cosine of pi over 6. You can do that. And the reason is cosine's an even function. So maybe you remember this from an identity. If you have the cosine of negative x, it's equal to the cosine of x. And this is true for all x. So you can do that. Whenever you have a cosine and a negative, the cosine eats the negative signs. It just becomes that. Now this is a little bit easier because the cosine of pi over 6 is something that hopefully you have memorized. So the cosine of pi over 6 is going to be, well, let's see. The cosine of pi over 3 is 1/2. That's how I memorize it. And so the cosine of pi over 6 is the other one. It's the square root of 3 over 2. All right. So now what you can do is you can give this a name. So let's call it y. And so y is in the range of the inverse cosine. So let's specify where that is. Y is in 0 pi. So this is 100% from memory, right? You want to memorize the range of the inverse cosine. You can even say this at the beginning, right? You can call it y and say, oh, okay, y is in 0 pi. You can do that right at the beginning. It's important to know it. So now we can get rid of the inverse cosine. So cosine inverse takes this number here and sends it to y. So that means the cosine function undoes that. It's the inverse function. So it takes y and sends it back to the square root of 3 over 2. And then y is in 0 pi. You say, okay, what is that angle? What angle is going to give us a square root of 3 over 2? Well, y equals pi over 6. And that's the final answer. I hope this video has been helpful. In this problem, we're going to work out the cosine inverse of the cosine of 3 pi over 2. So it's really important to make sure that you don't just cancel these. That's really bad. You want to work from the inside out. So the first step is to figure out what is the cosine of 3 pi over 2. So for this one, we can think about the unit circle. So on the unit circle, every ordered pair has the form cosine theta, comma, sine theta. And let's go ahead and label the important angles. So we have 0, pi over 2, pi, and then down here we have 3 pi over 2. So we're looking for the x coordinate here. So this ordered pair on the unit circle, which my circle is really bad, is 0, -1. Okay, so that means that the cosine of 3 pi over 2 is the x coordinate, so it's 0. So this is actually equal to cosine inverse of 0. Okay, so now we have to figure this out. So let's be really careful here. So I'm going to call it y, just so we have a name for it. And let's get rid of the inverse notation here. So this would mean that the cosine of y is equal to 0. Intuitively, the reason is, if the inverse function takes 0 and sends it to y, that means the cosine function takes y and sends it back to 0. Now let's say something about y. Y is a special number. It's in the range of the inverse cosine. So y is in 0 pi. Super important to memorize this. So this is key for doing this problem. So you need to have like a lot of trig knowledge. It's an innocent looking problem maybe, but like it's not. Like it requires a lot of knowledge. So this must be memorized absolutely. So now we think about, again, the unit circle. What is the angle y that gives us 0 that's between 0 and pi? Well, it's going to be pi over 2, right? Because here it is, 0, 1, cosine's the x coordinate there. So therefore, y is equal to pi over 2. Really sneaky, right? Because if you were to just cancel, you would get 3 pi over 2. But that's not the case. So I hope this video has been helpful. Good luck. In this problem, we have to work out the cosine of the tangent inverse of -2. Let's go ahead and start by calling this piece here by a new name. Let's call it theta. So theta is equal to tan inverse of -2. And our goal is to create a triangle for theta so we can evaluate this expression, because we have cosine of theta now, right? This is equal to cosine of theta because we called this piece theta. So if we can draw a triangle for theta, then we can just finish this problem. So to do that, let's start by getting rid of the inverse function. So the tan inverse of -2 is equal to theta. That means it takes -2 and gives you theta. So tan inverse is an inverse function. Its inverse is tangent. So tangent should undo that. It should take theta and send it back to -2. And so now we can use something from trig. SOHCAHTOA. So we can use SOHCAHTOA. So this means that tangent is opposite over adjacent. So you can think of this as -2 over 1. So it's opposite over adjacent. So now we can draw our triangle using this information. So here is our theta. The opposite angle would be -2. So I'm just going to use 2. Just keep in mind that it's going to be negative, okay? Being a little sloppy here. And the adjacent is 1. And then we can use the theorem of Pythagoras to find this number here, which I'll call b. So b squared is equal to 2 squared plus 1 squared. So b squared is equal to 4 plus 1. So b squared is equal to 5. When you take the square root, you get a plus or minus 5. I'll just leave it as plus. So this is the square root of 5. All right, so now we can finish this problem. So we know that the cosine of theta is going to be adjacent over hypotenuse. So in this case, the adjacent is 1, and the hypotenuse is the square root of 5. And you could rationalize this. You could write this as the square root of 5 times the square root of 5. So this would be the square root of 5 over 5. And that should be the final answer. Note, we were pretending the 2 was negative, so it didn't involve the other ones, so they both end up being positive. That's it. Hi everyone. In this problem we're going to evaluate the sine of the arc cosine of 1/4. Let's go ahead and go through it very carefully. Solution. So the arc cosine of 1/4 is not like a familiar angle to me. So what we'll do is we'll start by calling this piece theta. So I'm going to let theta be equal to the arc cosine of 1/4. And now we can get rid of this inverse notation, this arc cosine notation. The arc cosine is the inverse cosine. So it takes 1/4 and it sends it to theta. So to undo that, we have to use the cosine function. So the cosine function takes theta and sends it back to 1/4. And so now what we'll do is we'll draw a triangle for theta using an ancient proverb. So ka toa. Really powerful stuff. So here, cosine is ka, so it's adjacent over hypotenuse. Really beautiful mathematics. So now we can use this to create our beautiful triangle. So here's our triangle, and then here's our theta. And so the adjacent is going to be 1, that's this side here. And the hypotenuse will be, here's the 90-degree angle, so the hypotenuse is the one that's opposite of it, so that's this one here. And then we need to find this other angle here, which I'll call little b. And so now we can use an ancient theorem, the Pythagorean theorem, to find b. It says that 1 squared plus b squared is equal to the hypotenuse squared, so 4 squared. So that means that 1 plus b squared is equal to 16. Then you can subtract 1 from both sides. So we end up with b squared equals 15. Taking the square root of both sides, we do get a plus or minus, but we only want the plus because b is the length of a side of a triangle, so it can't be negative. So b is equal to the square root of 15. I like to go back in and fill my triangle. This type of thinking comes up in other areas of math, like calculus, and a lot of times you have more complicated expressions, so it's just a good habit to go back in and fill in the triangle when you're done. Okay, now we can finish the question. So this is equal to the sine of theta, right? That's what we started with. We called it theta. And now we can use SOHCAHTOA to finish. So it's opposite over hypotenuse. So the opposite is 4. Whoops, opposite. The opposite is the square root of 15, opposite the angle, right? And then the hypotenuse is 4. Really bad place to mess up. So it's opposite over hypotenuse. I hope this video has been helpful. Good luck. In this problem, we have to evaluate the cosine of 2 times the arctangent of 4/3. So to do this, we're going to use a trig identity, and there's several we can use actually. So recall that the cosine of 2x, this is equal to, and the one I tend to remember the most is it's cosine squared x minus sine squared x. Right? There's other ones you can use. This is also the same as 2 cosine squared x minus 1, and it's actually also the same as 1 minus 2 sine squared x. So you can use any of these in this problem. I'm just going to focus on this one because this is the one that I tend to memorize, and then I get these from manipulating this one. So maybe it'll be the case that you tend to also memorize this one. So let's start by giving this a name. Now instead of calling it x, I'm going to call it theta because it is an angle. So we're going to let theta be equal to the arctangent of 4/3. Okay, that's our theta. And let's go ahead and apply our identity. So this will be the cosine of 2 theta now because we called it theta. And this is equal to cosine squared theta minus sine squared theta. So all we have to do to finish is figure out what this is. So to do that, we're going to come back over here and we're going to use this equation to create a triangle for theta. Once we have a triangle for theta, we can figure out this piece over here on the right. So the arctangent takes 4 over 3 and sends it to theta. So it's an inverse function. So tangent should undo that. It should take theta and send it back to 4 over 3. And now we can use SOHCAHTOA to draw our triangle. So SOHCAHTOA. So remember, this is opposite. So tangent is opposite over adjacent. So I'm going to go ahead and draw our triangle like this. And then here's our theta. And so it's opposite, which is this one, 4. And then adjacent is this one down here, so 3. And this is the right angle, so this is the hypotenuse, which I'll call B. I know people call it C, but I like to use little b. And now we can use the theorem of Pythagoras, which says that b squared is equal to the sum of the other side squared, so 4 squared plus 3 squared. So b squared is equal to 16 plus 9, which is 25. So when you take the square root, you do get plus or minus 5, but we just take the plus, okay? Because it's the length of the side of a triangle. All right, now let's fill in the answers here. So here we have cosine squared of theta. So cosine is ka, adjacent over hypotenuse. So that's going to be, the adjacent is 3, the hypotenuse is 5. So 3 over 5, and then it's squared, right? Adjacent is 3, hypotenuse is 5, 3 over 5, and it's squared. Minus, and then sine is opposite over hypotenuse. So it'll be 4 over, and then 5 squared, because the opposite is 4, and the hypotenuse is 5. This will be equal to 9 over 25 minus 16 over 25. And how convenient, they have the same denominator, so 9 minus 16 is negative 7 over 25. Really nice problem, a little bit harder than some of the other problems you're probably doing if you're studying this stuff. It's kind of fun though, you get to use an identity and you get to draw a triangle, and it's kind of nice. I hope this video has been helpful. In this problem, we are going to work out the tangent of 2 times cosine inverse of 1/4. Before we do this problem, let me show you an identity that we're going to use. So recall, if you have the tangent of 2 times x, this is equal to 2 times the tangent of x, all divided by 1 minus tangent squared of x. So here our x is going to be this piece here. I'm going to give it a different name though. I'm going to call it theta, since it's really an angle. So theta is going to be cosine inverse of 1/4. And since I wrote the identity down, let's go ahead and apply it. So this is really tangent of 2 theta. Already it's better. And this is equal to 2 tangent of theta over, and then on the bottom we have 1 minus tangent squared of theta. So now we just need to figure out what this is. So to do that, we're going to come back over here and use this to draw a triangle for theta, and then we'll be able to finish the problem over here. So to draw a triangle for theta, we need to get rid of this cosine inverse. To do that, we can just use the definition of the inverse function. So the cosine inverse takes 1/4 and it gives you theta. So the cosine function should undo that. The cosine is the inverse of the inverse. So the cosine takes theta and sends it back to 1/4. And now we can use SOHCAHTOA. So SOHCAHTOA. And that means that cosine is adjacent over hypotenuse. So it's going to be A over H. So using this, we can draw a beautiful triangle. So here's our triangle. Here's our theta. And so the adjacent side is this one down here, so 1. The hypotenuse is this one. It's the one that's opposite of the 90-degree angle. And we're looking for this one here, so I'm going to call it b. So then we can use the theorem of Pythagoras that says the hypotenuse squared is equal to the sum of the other sides squared. So 16 is equal to b squared plus 1. So that means that b squared is equal to 15 because you can subtract 1. Taking the square root, we get plus or minus the square root of 15. So here b is the square root of 15. So I'm going to come back over here and fill it in, square root of 15. Now we should be able to finish our problem. Let's do it right away. So this is 2 times the tangent of theta. But tangent is opposite over adjacent, TOA. So the opposite angle is the square root of 15, and the adjacent is 1. So it'll be the square root of 15 over 1, divided by 1 minus, and then here it's the same thing, except it's tangent squared. So it's opposite over adjacent. So it'll be the square root of 15 over 1, and the whole thing is squared. So this is equal to 2 times the square root of 15. Then on the bottom we get 1 minus, when you square the square root of 15, you just get 15. So this is equal to 2 square root of 15. Then 1 minus 15 is negative 14. Beautiful stuff. And this is equal to, I'm going to come over here, I'm running out of room. I guess it's going to be 7 on the bottom. So it'll be negative square root of 15, all divided by the number 7. And that should be the final answer. I hope this video has been helpful.